So far we've talked about the electrons in the atom and how they can gain and lose electrons to become ions or charged particles. But how does this actually happen? Well, it turns out that in order for an atom to gain or lose electrons, those electrons have to go somewhere, or they're not going to leave the atom. So here I have two atoms. I have a sodium atom with 1 valence electron, and I have a chlorine atom with 7 valence electrons. According to what we've discussed before, sodium, having only 1 valence electron, will tend to lose that electron to become positively charged, and chlorine will gain that electron to become negatively charged. But how does this actually happen? Well, if I have two atoms, one that wants to lose electrons and one that wants to gain electrons, they're going to trade those electrons. So in this case, I have the sodium, and it's going to lose this valence electron. It's actually going to give or donate that valence electron to chlorine. So to represent this in a little simpler way, sodium has 1 valence electron, chlorine has 7. Sodium will donate its electron to the chlorine, leaving us with a positively charged sodium and a negatively charged chlorine. And as you may notice, so now we have two charged particles or ions. Well, what will happen next? Are these ions done? Are they not going to do anything? But you may notice that one has a positive charge and one has a negative charge. What do opposite charges do? Well, they attract each other. So the sodium and the chlorine, the positively charged sodium and the negatively charged chlorine, are going to be attracted towards each other to make what is known as an ionic compound, a compound made up of ions. So let's talk a little bit more of what types of elements will actually make an ionic compound. As we just saw, ionic compounds must form between a positive ion and a negative ion. So there must be one element that loses electrons and one element that gains electrons. If we look at the periodic table, we've already discussed which elements lose and which elements gain. So we can see the whole left side of the table tends to become positively charged, and the right side of the table becomes negatively charged. So what does that tell us about ionic compounds? Well, ionic compounds form from a metal and a nonmetal. The left side of the table are the metals, the right side of the tables are the nonmetals. And because metals become positive as ions, also known as cations, positive ions, and nonmetals become negative as ions, also known as anions. You must have one of both, or at least one of each type, in order to form the positive ion and the negative ion that you need for an ionic compound. So what exactly are ionic compounds? Well, another word for these ionic compounds is actually salts. So salts are ionic compounds. And the properties of ionic compounds are very similar to what we normally think of as table salt. So this would be the normal sodium chloride that we usually have, NaCl, what we eat. But there are many other types of salt, but they all share some very similar properties. And these properties include, they are a crystalline powder. They are hard. Many are soluble, and that just means they're able to dissolve in water. they actually, when dissolved, they can conduct electricity, and they also have very high melting points. For example, the melting point of table salt, sodium chloride, melts at 800 degrees Celsius. And in Fahrenheit, that's about 1400 degrees Fahrenheit. So they have very, very high melting points. Well, why do they have all of these properties? And like many things in chemistry, almost everything in chemistry and even biology, the structure of whatever we're talking about, how it's put together, determines what the function, what are the properties of this compound. So this is a diagram of a salt or ionic compound on the atomic scale. And as you can see, we have positive charges and negative charges, and each positive charge attracts negative charges, in this case chloride ions, all around it. And each negative charge attracts positive charges, sodium ions, around it. And this forms a repeating pattern, also known as a crystal. So this is a crystal. It's just a repeating pattern of atoms. And because we have this repeating pattern, on a large scale, you get big crystals of salt. And this repeating pattern can be seen on the larger scale. So here are some zoomed in pictures, close-up pictures of salt. And you can tell that this square repeating pattern of the crystal, because this is copied over and over again, can actually be seen, the same shape can be seen on the macro scale, something we can actually see. This crystal pattern also disperses light very easily, and this makes many ionic compounds white. Well, not all of them are white. There's some red ones like rust, and there's some blue ones like some copper compounds when they have water in them. But for the most part, ionic compounds are white, again because of this crystal structure. Lastly, why do they have such high melting points? Well, for something to melt, the structure needs to be able to move. So these ions need to be able to move around each other. Ionic bonds are really, 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 really strong. So because we are positive charges next to negative charges, positive charge, negative charge, it takes a lot of energy in order to get these particles moving fast enough to break these ionic bonds. So these strong ionic bonds make it so you have to reach very high temperatures to melt an ionic compound.